check model, choose to click the URL, the link, URL available until, let me look on, yeah, precisely 7 days. So 7. Okay, and maybe prepare 60 to 90 minutes or more. Okay, or more. This is around. So check Moodle. Check the date. I think on 3/28. I think check this week. Okay. Okay. And I hope this test can help you also to improve your preparation on midterm, especially on chapter 11. So please check out the link. And probably in several questions, the difficulty will be the same with the midterm. So I think it will also help you. I have set the test to be so that the questions paper at the end of the test will be available. I think you can download, I think, or you can take a screenshot if you want, and you can maybe have another try in paper and try whether you can, if it's not limited by time, can you solve the questions, and maybe you can have more practice. Okay, so for today, I just continue a little bit of vectors, and hopefully I can give you a clear guideline on how we can actually apply vectors, and especially in calculus. And you will learn more about that in a vector function. Okay, but before that, is there any part of maybe chapter 11 or maybe chapter 10 that you still have confusion, or maybe something, maybe the concept is not really well understood? Is there anything, or maybe which part you think more difficult? Like, for example, in chapter 11, we have a lot of sections, right? We have a lot of sections, and probably which part that is still maybe need time to process and not really familiar with. Anyone want to discuss which part? I might add it maybe more additional videos for you. So I think because our class now we have chapter 12, 13. Hopefully we can finish at the like 2 or 3 weeks. This is 2 chapters, and our focus is actually not really about vectors, but how to apply the calculus in vectors. So I hope you don't mind. So we don't really going into deep in a vector. So I'm just going through. Okay, so last time, okay, so for those who are just coming, please check your Moodle, and you can have more more exercise, or probably test your ability to solve some questions. Okay. So last time we have defined vectors, and let me maybe going back a little bit. Okay. So I think here, at least for vectors as introductions, as you know, I believe all this stuff as introduction is pretty much familiar with you. So I will not really go into more details on this one, but probably I will just make sure that you remember how to find the value or the magnitude on a vector. Okay. Sometimes not really well remembered. This one, okay. And also the distance formula. I think the distance formula not really complicated, I think. Okay, let me just take some. Let me write here if there is a picture. Maybe this one, no. This one, okay, I think this one. And let me just give you some review on vector properties. Okay. So as you see that you can reverse the addition, so you can have a scalar and some other, I believe, familiar properties in a vector. So basically vectors, as in principle, everything that has value and has directions, we can set up those things as vectors. Okay. I think no problem here. What else? Okay. Okay, finish the attendance. Okay. Sorry about the system. Okay, maybe I will check whether it's maintenance or not. And the other idea is about the dot product. Okay. Let me just give you this property of dot product. What is dot product? Or maybe before this, let me just maybe take some notes here. We can write a standard basis vectors. Usually we can write this as I equal So what is standard basic vectors? Basically, they have their length is precisely 1 unit. Okay? And they have directions of positive. Let me write positive x axis, y axis, or z axis. And sometimes we can write the vectors as in terms of this I, j, and k. So we can write vectors like maybe 1, 2, and 5, or we can write this as 5i. what's I plus 2j plus 5k. Okay, and I think that's the 12.2. So the 12.3, we'll start with the dot product. Before we go into the property, let me go for the definition first. Okay, so definition. This is 12.3 dot product. So definition. So that if A, or let me write A as a vector A. I will write every vector with the arrow on the letter, above the letter. So I think that will be better to distinguish vectors and non-vectors. So vector A is A1, A2, A3, and vector B so dot product of A and B we can write as A dot B like that, or sometimes the dot is not really on the bottom, so it's like in the middle here, so we call that as a dot. So it's a tools, actually a tools, a mechanism to multiply a vector and then adding each part. Okay, so this will be A1, B1 plus A2, B2 plus A3, B3. And of course, for those dot product, we will have some rules and some property, which we have here. You can dot the additional vectors here. I think this is by intuition, I think pretty clear. And you can reverse the dot, okay? Because it's actually just multiplication and addition, so there's no problem here. And I think for number 3, A dot B plus C is A dot B plus A dot C. I think you can prove that by yourself, right? So you can let A like this, B, and then you have another one C, and then either you can start with adding B plus C, or maybe you can start by this. By the end of the day, you will get left side and right side equal. I think pretty much this is easy to prove in number 3. Okay. Okay, another thing that's important in the dot product is, let me input another one. Okay. Another one that is important is the angle theta in between of the vector A and vector B, and we can see some relation on dot product. So if the theta is the angle between let me just write vectors A and B. then A dot B, or maybe let me write all with arrow. It's the magnitude A, magnitude B, cosine theta. To prove this is using the law of cosine. Law of cosine, let me write here, based on the triangle we have. This will be the law of cosine. If you still remember, law of cosine is adding and then minus 2 OA OB. And then cos theta. And also we can write the cos theta in terms cos theta factor A factor B divided by magnitude A and magnitude B. So then from this angle, we can also say if we have a vectors that is orthogonal, which means we have, for example, if our vectors, for example, this is A, this is B, this is theta, which means that the dot product between the orthogonal vectors will be a 0. If this happens, if theta is orthogonal, or theta will be pi over 2, which means that the factor A dot factor B will be 0. Okay. Now from this dot product, from the angle that we have from the these two factors, the theta, we will have another term which is called the direction angle. So direction angle, if we take a look, okay, let's say we have a vector that is going to be here. Let's say this is our vector, vector A. Okay. Now, what direction angle means? Okay, what direction angle means is every part on this axis, they will have an angle to the vector A. For example, the x-axis, it can have an angle here. The z is angle here. Okay. I think maybe it gives me an idea. Maybe next time, maybe I'm taking maybe some 3-dimension models and then showing you which the direction. I hope this is clear enough. That we have an angle. Let me just draw the angle. Let's make the angle name from x-axis here to the A. This is alpha, okay, and the other angle from y-axis, let's take it to beta, and from z is gamma. Okay. Okay, now so direction angles is the angles alpha, beta, and gamma on interval from 0 to pi. That is in between vector A to axis, or maybe with positive axis, positive x, y, z axis. This is direction angles. And then if we connect this conditions to the dot product we have, the cosine we have, we also have the direction cosine. The term's called the direction cosine. So direction cosine is basically proportional to the angles. Okay. So this means that this is the cos alpha, cosine beta, and cosine gamma that we already had. Now, to see what is cosine alpha, we can see that the cosine alpha, if we write this become A, and then remember that we have the identity or standard vectors for x-axis is I. Let me just dot this A with the standard vectors of x, which is I. Okay? Standard vectors. So we can write this as A dot I. This a standard vector. One, 0, 0. And basically, if we using the dot product formula, we get that this is becoming a new A. Let's say this x-axis on the point that is maybe that has 1 unit length is A1. So let me just write this as A1. Okay. So this become A1 over magnitude of A. And then the same thing with J and K for cosine beta. This will become, let's say this is become A2, and cosine gamma become A3. So let's say the A2 is here, the A3 is here. Okay. Okay. The idea is still the same, using the dot product, and we can apply the dot product to take in the definitions to the direction angles and direction cosine. Okay, that's the direction angle and direction cosine. Can there be any questions? Okay. I think this is just to name the concept, keeping the name for the concept, and giving a sense of direction. So every vector in the three-dimension system, they can have at least some property that can be separated into each angles and in each direction. Okay, another sections that still important in the factors is we usually use some projections. So we can project some vectors to some other vectors. Okay. Okay, let me check if I have the graph. Do I have the graph? Oh, okay, no. Let me just take. Okay, let's say this is vectors. Okay. Now, if this is two vectors, maybe vectors A and vectors B. Now, if we project vector B to A, project like this, okay, and we have another line here, which we call this is a projections of B onto A. So they both have the same initial point. Let's make a point P, Q, R, S. And it doesn't need to be like having like a triangle like this. We can also have, if you want to make maybe a little bit more, maybe this is B, and this is A, then the component or the projections, this is the projections. This is also the same projections of B onto A. You can think this as a shadow, right? Shadow of the vectors. It's giving you visuals of shadow. Okay, this is a projections, a vector projections. Now, if we, let me make another one. If we take this, similar vectors, and if we have an angle between these two, and we take the projections, now this line here, if we just look on the scalar, okay, the length itself, this length will be just b cosine theta, right? Okay, in terms of theta. Or we can write this as a component of b along a. And of course, if we look on the perspective in the dot product, if we take this, the magnitude b and cosine theta, this will be a dot b over a, or we can write this as a magnitude a dot b. Okay, so as a conclusion, scalar projection of B onto A, or we call this is a component. This is, we sometimes write component A, B like that. We can read this as component of B along A. We can write them as component comp A, B. This is equal A dot B divided with magnitude of A. I think I need to add arrow here. But actually it's up to you how to write vectors, using the dash arrow or just write the letters. As long as you consistent using those writing. Okay, so this is scalar projections. The other one is the vector projections, which we already discussed at the beginning. So vector projections we can write as of B onto A. We sometimes write B arrow G proj A B like that, and then equal. Remember that we have this definition, and our B cos theta we can rewrite as this, okay? Or maybe this, okay, to be precise. So we can exchange this into our equations. So we can write down A dot B and then A and over A. Or
we can write it more clearly that this is A dot B over, because magnitude is a scalar, so we can take square, and then this is A. So this is scalar projections. This is a vector projection. Okay, and that's all about the dot product.
I think you learned vectors the very first time is high school or junior high school? High school. High school. Okay.
Okay, another sections. Okay. So this is all dot product, all the terms that sometimes we are going to see. Okay, some projections, the direction, angles, direction, cosine. Okay. But in any way, the point of dot product is
Actually, the core concept is just this formula. All the terms is based on this formula. Okay? And sometimes if you maybe a little bit do not remember the details, for the projections you can draw the factors and imagine this being taking the shadow from the B, and you can take the component first, and you can say, okay, because it's having an angle here, we can have the magnitude P cosine theta for this component, and then from this component we can exchange the dot product for the projections for the vector itself,
and you will end up with the same formula.
For this projection formula.
Okay. Okay. Now the next one is the cross product. Okay. The cross product is a little bit difficult to imagine. Okay, if you try to imagine. So let me write the cross product. Okay, what's the idea behind the cross product? Okay. The idea is you have a vector, let's say vector A, and maybe vector B is here. Okay. Now the question is, okay,
If these two vectors, for obvious reason, it's non-zero vectors, what is the other vector that we can find from these two vectors that is perpendicular to both of them? That's the idea behind the cross product.
So what is the vector? Idea is what is the vector? The non-zero vector that perpendicular to both vectors A and B.
And if you remember how to use your right hand rules, that's how we apply the right hand rule. So we can say A cross B, B cross A, something like that. So before we develop the formula, and sometimes you remember the formula throughout the, I think when you learn matrix also, we also using the cross product formula. Let's try to given the vectors some terms. Okay, so giving two non-zero vectors. And let's suppose we have another vector that is, let's say, non-zero C, non-zero vector C, C1, C2, C3, and this vector C is perpendicular to vector A and vector B, which means because they perpendicular to vector C, so if we take dot product, A dot C is supposed to be 0, and B dot C is supposed to be 0 also because of perpendicular. Perpendicular means orthogonal or having 90 degree. Which means if this is happening, probably C is something that going around maybe here, or maybe here. Depends on which one you are going to have, okay, B cross A or A cross B. But anyway, let's look on here, which we can develop these two equations at least. A1 C1 plus A2 C2 A1 C1 plus A2 C2 plus A3 C3 is equal 0, and B1 C1 plus B2 C2 plus B3 C3 equals 0. Okay, we multiply the first equations with multiply with B3. Multiply the second equation with A3. And subtract both of them. So this will be A1 C1 B3 plus A2 C2 B3 plus A3 C3 B3. And this will be B1 C1 B3 plus B2 C2 A3, sorry. Plus B3 C3 A3. Do you want to have a short break, or we go on and maybe having a early class? We finish early. Do you feel with that? Or is there any course after this class? Anyone still have any course? No? No? Do you have? Okay. No? Okay. Do you want to have early finish for today's class? No? Do you want? If not, then I will just continue and maybe we can finish early. Is that okay? Is that okay? Is that okay?
Okay. Okay, now we are subtracting this. We are canceling A3, C3, B3 with B3, C3, A3. This is canceling. And this is supposed to be A1, B1, or A1, B3, sorry. And plus A2, B3 minus B2, A3, or A3, B2. Let me write A first. Supposed to be 0. Now, if we solve this and look on the solutions for C1, this is for obviously this will be equal with A2, B3 minus A3, B2, and C2 will be the other one. And then substitute into equation 1 and 2. We get C3 is equal A1, B2 minus A2, B1. So the solutions for C1, C2, and C3 as a vector, we can write them A2, B3 minus A3, B2, and then A3, B1 minus A1, B3, and then A1, B2 minus A2, B1. Now this is called the cross product of A or factor A and factor B, or we can write the cross product as A cross B like this. So as in definition, if A A1, A2, A3, B factor B, B1, B2, B3, then A cross B is A2, B3, okay. Of course, if you remember this cross product just by text, I think will be very difficult to apply if you are applying in some cases, right? All this text, I think not really easy. I believe
the better way to approach the cross product is, I think, using matrix. Using matrix is a better approach.
Okay. Okay, now if we remember what we learned in matrix, we learn about the determinants, right? The determinants. The simplest determinants, order 2. We can set up A, B, C, D like that. And we can write AD minus BC. Some multiplications, AD minus the BC, right there. Now if you have, this is order 2. Now for order 3, you can set up A1, B1, C1, A2, B2. Now how we are going to set up in the matrix, this will be, if I take A1, A2, A3 as my covector, if you remember the matrix, we can write this as A1, and this will be B2, B3, oh, it's C2, sorry, C2, C3, and then minus okay. Now you can see that how we can get this B2, B3, C2, C3, and another one. This is perfectly from, we can look on A1, and we can cover the row and column. And the same way, we can also cover A2, row and column, and A3. So we can get the other part of the order 2 determinants. Okay. Now, it's not only A1, A2, A3, we can also take B1, B2, B3, or C1, C2, C3. Okay. So this will be equal also if you, for example, take B1. So this will be A2, A3, C2, C3. But I think for B1 this will be negative, and for B2 is positive. A1, C1, A3, C3. And then minus B3. A1, A2, C1, C2. And how to get the signs? The signs is this is positive, negative, positive, negative, positive, negative, positive, negative, positive.
Okay, if you want to know more, I think you can review the matrix, the matrix. And you can also do the same thing with the C1, C2, C3. You take it as a cofactor.
Okay, now for our case, we usually write A cross B. Okay, so we are just using two vectors, right? And we are just taking the three order or order three determinants, and the first one will be I, J, and K, the standard basis factors. And then A1, A2, A3, B1, B2, B3. And this is perfectly giving you A2, A3, B2, B3. This is I. And minus for A1, B1, A3, B3. For J, and plus
This is, I think, fine for calculations. But I prefer another way to calculate.
we can actually also write the matrix Okay, now I believe this method is also popular, I think, among Taiwanese also, because I also learned the technique before. So you just rewrite I and J. Okay. And the idea is multiply this, 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 this. Oh no, just 3. Okay, multiply
I, A2, B3, and plus J, A3, A1, and plus K, A1, B2. That's one section. The other section, we are going to minus and then multiply the other way around.
So here,
either way, same result. Either way, same result. I think if you exchange A, B with numbers, I think the second one will be very, very fast. But you need to be careful on this is positive. The yellow one is the negative one. Anyone familiar with the second one? Familiar? No? Familiar with the second one? No? Okay. And you can try it. I got this when I think when I was still passing the I think the national exam in my country. I think this is very fast. And I'll help you a lot with math. But if you want to keep the official way like this one, I think it's good. I think you can also check some tutorials on YouTube and they will teach you maybe this method.
Okay, now the property for the cross product, as I mentioned at the early introduction of cross product, that the cross product need to be, we suppose it's supposed to be orthogonal to both factors. So the property for cross product, so that the A cross B is orthogonal to A and B. Okay. Of course, we can set up some calculations if you like, that maybe we start with the A cross B and then dot with factor A. And this is supposed to be 0, and you can try that as well. You can start with A having A1, A2, A3, B1, B2, B3. You can cross them and then dot with A. It is supposed to be 0. And also similar calculations will be resulting the same results. You can dot with B and it is also get 0. And now since we know that the property for cross product is the orthogonality to both vectors, then we can set up our idea on at least the right hand rules. So if we have a vectors A and vectors B here, we will have, if we say A cross B,
If you say A cross B, meaning from A crossing B and it's giving you direction to the top, right? Okay.
so this will be A cross B. And this is, and this, if this is theta, then if we want to find
The length, okay, the length of the product from the cross product, the vector from the cross product, we can set up
the formula, okay. So let me write if theta is angle between A and B, and theta need to be from 0 to pi in between, then the length of the cross product A cross B is equal with A magnitude A magnitude B sine theta. Now, how we get sine? There are some proof that I think I can write the proof. Okay, I think I can write the proof. Still have enough time. Okay, so if we start the equation A cross B, okay, we have or if we start A cross B and then we squared A cross B, so all the results of the cross product will also be squared. Squared all the results here. Okay, now one by one, we need to square A2 squared B3 squared minus 2 A2 A3 B2 B3 plus A3 squared B2 squared plus A3 A3 squared B1 squared minus 2 A1 A3 B1 B3 plus A1 squared B3 squared. Still one more plus A1 squared B2 squared minus 2 A1 A2 B1 B2. Oh, let me move. And then plus A2 squared B1 squared. Okay, I think we have all. Okay, now if we take some time to look at this, all this and we incorporate, let me write with some set of algebra, this become A1 squared plus A2 squared plus A3 squared and then B1 squared plus B2 squared plus B3 squared and minus A1 B1 plus A2 B2 plus A3 B3. This is squared. Yeah, for three components, the quadratic seems a bit complicated. But anyway, this we can simplify, become, this is our A squared, and this will be our B squared, and this whole thing here, this is a dot b. So we can minus with a dot b, and then still have squared. And then we can exchange this a dot b with the dot product formula. And then we can then factorize one minus cos squared theta. Now this is sign will be appearing. So the sign is actually from the 1 minus cosine squared. So this will be a squared b squared and then sine squared theta. And because the theta is from 0 to pi, so the square root of sine squared theta should be positive, not negative, right? So we have a cross b is a, b, and sine theta. And also from these equations, we know that if the vectors a and b parallel, it means that the cross will be just 0 because the angle is 0. Okay. Which means that from here, so that if a cross b is 0, then a and b are parallel. Or you can say vector a and b are parallel if the cross product is 0. Now the cross product, the length, we can actually compare to the parallelogram. So if this is vector P, this is A. If we have a theta here, and we know that this line will be the magnitude P at sine theta. So the area of this area of a parallelogram we can write as the magnitude of A multiply with the B, or maybe B sine theta, and we can write down that this is equal to A cross B. So we can set up A cross B, the length of A cross B is equal to area of parallelogram. Okay. Now another important thing about the cross product is if we set up a three-coordinate system, okay, and let's say we set up the I as our standard vectors. Let's say this is our I, and J and K. Of course, if we take our right hand and look on I cross J, it's going up, right? It's going up. Okay. So first, the basic rule for a sign, this is equal K. But if we cross from J to I, it's going down, right? So J cross I will be negative K. Okay? Now J cross K is going to be here. Okay? It's going to be a positive. So J cross K is positive I. And the opposite, K cross J is negative I. And K cross I is J. And I cross K is negative J. Okay. And if we observe, at least from this result, we see that I cross J is not the same with J cross I. So you need to keep in mind. Okay. So in a cross product, this is not commutative property. So we cannot reverse the equations. So if we have a vector like A cross B and then cross C, this will not the same A cross B cross C. So there are some property that can be applied on the cross product. So property. So A cross B, this is equal with negative B cross A. And if we have A cross factor B plus factor C, we still can apply the cross. And if you want to take the dot product and then take the cross product inside, we can exchange this with A cross B and then dot C. Okay, and then if C is a scalar, so without arrow, so CA cross B is scalar A, and then A cross B, and then equal A cross scalar B, and then if A plus B and then cross C plus B cross C, and then A cross B cross C, and this will be A dot C B minus A dot B and then C. This is, I think, based on the previous one that when we find the cross product. And sometimes we call the property, this one, we call this property as a triple products. Or to be precise, this is a scalar triple products. And I think one of the applications for that cross product is, I think in physics or in mechanical, is I think torque. It's defined by the length of the R and the crossing the force. Like this, if you have, maybe this is the length, okay, R, and you have maybe force, so it has a vector here,
cross R and crossing F.
You can exchange F to here. So the torque will be going over there. And we write torque like that. So this is R cross F. This is just some example on we are using the cross applications. Okay. The last sections, I will explain about this scalar triple products. Okay, the scalar triple products. So we can set up the triple products, okay, as we can set up. Let's say this is A, and let's say this is B, and let's say we have C that is going to be here. And these three vectors, we can set up a volume of, we called a parallelepiped. Now if we cross B to C,
B cross C, so it's going up. B cross C is here.
so let's draw. Let's draw. Maybe moving a little bit here. So this will be B cross C. Okay, let's project this vector, or rather project the vector A to this cross. And let's say this is becoming H, the length is H. And if we have an angle, so if theta is angle between vector A and cross product B cross C, okay, so this will be angle theta here. Then the volume of this parallelepiped, this is called the parallelepiped. The pipe. Okay, it's difficult to pronounce. Parallelepiped. Okay. So the volume will be equal to the area, the base area, multiplied with the h, right? Now we know that
The area is parallelogram, like we did in using the sign. So we can say the area of this is B cross C, the length of B cross C. Okay.
this one. Where is it? Here. The area like this, right? This is perfectly same as this. Okay. So area of parallelogram, factor B and C is equal to just cross product of these two. Okay. And then our h from the angle theta, we know that h will be equal to, if we are just looking on the value, then this is equal to magnitude A and then cosine theta, right?
You can treat this as a triangle, and the h is just a and then cosine theta. Okay? So we can have the volume
as volume B cross C and then A cosine theta. And this is equal to A dot B cross C, the length. So the volume of parallelepiped is equal A dot B cross C. And if the volume is 0, then A, B, and C must lie in the same plane. Or we call this coplanar. Okay, and I think that's it for the cross product. So I hope you can review, and I think you can also review from your maybe your physics notes if you have notes on vectors, or maybe your high school notes, and look on some definitions if you feel confused. Because I think now there are some new terms and definitions and some proof for several formula. So next week when we are having a class, we will move to I think 2 more or 3 more sections on the vectors, which is the equation of line, plane, and then the last part will be the quadratic surface. I think we need to still 2 more class. I think 1 or 2 more class for finishing all these vectors, and then we can have either a midterm, or maybe we move to chapter 13 first and then midterm. But the midterm exam will be chapter 10 and 11. And you can please skip some parts. I think you can skip some parts on chapter 11, like the binomial. I think we don't have that in class, so you can skip all the exercise using a binomial series. Okay. So any questions? And don't forget to click the link on the Moodle, and you can choose your day from now until before 7th of April. 7th of April. The deadline is 7 p.m.
So I hope before that you can check. And please write name and student ID. Okay? Name and student ID.
Okay, if there's no questions, let me end the session.